Hi folks, we're back talking about the unit circle here, and today we're going to talk about radians. Previously we talked about degrees, and all these starred spots around the circle here are the special spots from our special triangles that created a bunch of degrees around our full circle. So if we go back and review those, we started off at 0, or that'd be 360 degrees. And that was this first spot here. That's like the spot 1, 0 on the unit circle. Our next spot we've put down was 30, and that came from, if you remember, we put this 30, 60, 90 triangle in our unit circle that had a radius, or I'm sorry, well, I guess it is a radius or a hypotenuse of 1. And so all the radius or radii of all the unit circle triangles here that we used have a measure of 1. So then we looked at the cosine and sine values, and where these values, the reason we picked these values is because they correspond with these special triangles, and it's a little easier to manage because we're starting to talk about cosine and sine values of angles or degrees that are much bigger than 90. So we're going out of our realm of being just in a triangle. The next one was 60, and then I will just go around and highlight all of the angles that we've done. So this is the first quadrant right here. This is like 0 to 90 degrees. All this stuff would be in this quadrant would be applicable to triangle applications. And then we're going above that, and now we're talking about angles, essentially any angle, cosine or sine of any angle. So if I just go around there and highlight the rest of these are all the values that we've worked with so far. So what we're going to do today is we're going to essentially define another unit of angle measure called a radian. And a radian is a measure of essentially like arc length. So, just to get a feel for like arc length, let's remind ourselves of the circumference. So if we look at the circumference of this circle, okay, circumference, if you remember, is calculated by taking the diameter of the circle times pi. I like to ask students this question. I like to say, hey, what is pi? And they'll most oftentimes say it's 3.1415, blah, blah, blah. And then I say, well, yeah, that's what the decimal approximation is, but what is pi? And remember, pi is just the circumference divided by the diameter in any circle. And so if that's true, then the circumference, if you rearrange that equation and solve for c, the circumference is equal to the diameter times pi. Okay, so we know our diameter of the unit circle. Our unit circle has a diameter of 2 because the radius is 1. So our unit circle diameter is 2. Okay? Well, then that means the circumference, or all the way around the unit circle, if I calculate the length all the way around the circle, that's equivalent to 2 times pi, because the diameter is 2 and the circumference is pi times diameter. So my whole length all the way around the whole circle, the unit circle, is 2 pi units. Okay? So essentially, radian is a measure of arc length. Well, if I take the whole arc of the whole circle, that's essentially the circumference, which is equivalent to 2 pi. I'm going to clean this up now and get rid of that. Okay, now we're gonna put some values on the board in radians here. So let's start out by defining 0 or 2 pi is the same as 360. going around, that's just what I talked about, all the way around the circle, 360 degrees is the same as going 2 pi radians. So 2 pi is equivalent to 360. All right, well then let's take half of 2 pi. Halfway around the circle is 1 pi radians. So 180 degrees is equivalent to 1 pi. All right, well, let's just keep chipping this in half. If I go half of a half and I go 90 degrees, that's equivalent to half pi, or pi over 2 radians. So let me just stop here and say that 90 degrees is the equivalent to pi over 2 radians. Okay, it's a measure of the arc length with a unit circle has a radius of 1. So that's pi over 2, or 90 degrees. All right, well, let's count by pi over 2's then. I have 0 pi over 2, or 0, excuse me, 1 pi over 2, 2 pi over 2, which is just the equivalent to 1 pi, and then the next 90 degree increment is 3 pi over 2. Okay, let's take half of a half. Half of pi over 2 is pi over 4, which is 45 degrees. 45 degrees is the same as pi over 4 radians. All right, well, let's count by pi over 4. So let's go 0, or 2 pi, pi over 1 pi over 4, 2 pi over 4, which reduces to pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, which reduces again to 3 pi over 2, and 7 pi over 4, and then finally 8 pi over 4. So those are all my multiples of pi over 4, or 45 degrees. Now notice up here it reduces to pi over 2. Over here it reduces to pi, and down here it reduces to 3 pi over 2. So really we don't ever say 6 pi over 4 radians, you'll say 3 pi over 2 radians. All right, the rest are not halves of anything, they're thirds. So 30 degrees is really 1/3 of 90. And if 90 is pi over 2, then what's 1/3 of a half? Well, remember, of means multiply. So what is 1/3 of 1/2? 1/3 of a half is 1/6. So every 30 degree increment is 1/6 of the way around a half of a circle, really. And you'll see we'll count by 6, or pi over 6. 30 degrees is pi over 6. 60 degrees is 2 pi over 6. However, that reduces to pi over 3. 120 degrees, well, actually, we go 90 degrees is 3 pi over 6. Of course, that reduces again. 120 degrees, that's going to be 4 pi over 6, which reduces to 2 pi over 3. So I got, let's go back, 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6. What's the next one? 5 pi over 6, 6 pi over 6, whoops, there it is, 6 pi over 6, 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6, 10 pi over 6, which again reduces to 5 pi over 3, and then 11 pi over 6, and finally we get to 12 pi over 6. So there is pretty much the whole unit circle in radians. There's another 6 pi over 3. I put all these extra ones here because I feel like when you are first learning radians, it helps to count by like increments of 30. So we can go around 1 pi over 6, 2 pi over 6, but that's the same as pi over 3. 3 pi over 6, 4 pi over 6, so on and so forth, all the way around the circle. I had to pause it there, sorry. I don't know where I left off, but looks like the whole unit circle is developed with radians, and really all these extra ones, I think that's what I was talking about. All the extra ones here that you see are not really, we really don't say like 2 pi over 6. We would say that's pi over 3. 60 degrees is pi over 3. So all the ones on the exterior there, we really don't use those and say, 4 pi over 6 or something. I think on the next slide here, then we can clean this up a little bit and we can get rid of some of these. So if we clean all this up, we don't need all those extra ones there. Okay. 10 pi over 6 is an extra. 2 pi over 6 is pi over 3, so we can get rid of that. These two up here are the same as pi over 2, so we can get rid of those. 4 pi over 6 is reducible. Same for all of these three. Those are all just pi. And so I'll clean up this whole unit circle radians. And what we have left is right there. These are the values that you want to become familiar with and be able to evaluate cosine, sine, and tangent values of these angles. So when we say, for example, we say 30 degrees, you need to know that that's pi over 6. If we say 3 pi over 4, that's the same as 135 degrees. Wherever it is, somewhere on there. Pi over 3, 60 degrees. Well, 3 pi over 4 must be deleted somehow. Anywho, these are the ones that you want to become familiar with. That is a measure of a radian. That's 1 radian. And of course, that's not the only measures of radians. You can have all the measures in between those two. So if you want to convert from radians to degrees, there's really just a simple conversion factor that you'd multiply by. So I'll show you that before I wrap this up. Let's say we wanted to find how many radians is in, 70 degrees. Okay. Well, if we want to know how many radians are 70 degrees, we need to multiply that by pi over 180 degrees, which will convert that to radians. You can come in, it's fine. So if I convert that to radians, then that would be essentially 7 pi over 18. So that's the conversion factor from degrees to radians. 7 pi over 18, that's equivalent to 70 degrees. They're the same. Both talking about the same thing. Similarly, if you want to go the other way and you want to go from radians to degrees, then you multiply by the reciprocal of that. Let's say we want to know what, let's do an easy one. 3 pi radians. How many degrees is 3 pi radians? Okay, well, you'd multiply that by 180 degrees over pi, and then simplify that. So then once you simplify that, your pi's cancel out, and 3 times 180 is 540 degrees. So that's how you go back and forth from radians to degrees and vice versa if you need to do that. So that's what a radian is and how to use it. You need to know the whole unit circle in degrees and radians. So you should start to become familiar with radians as well as degrees. That's it.